Welcome. My name is Pratap, and I'm a partner solutions architect with AWS. I help AI and machine learning partners build solutions on top of AWS. In this tech talk, I will show the steps to run Jupyter Notebooks on AWS and to securely access the notebook from your laptop. When I first started using Jupyter Notebooks, I installed the software on my laptop and accessed it using a browser. Life was simple because everything was running in one computer, right? I believe many of you may be familiar with that setup. However, when I graduated to the next level, I installed Jupyter in the cloud. I had to cross several hurdles. That was the motivation to create this talk. I want to share my learnings with you. Before we start, I want to mention that I will not be talking about any specific deep learning algorithm, but I will enable you with the right set of tools to run your own deep learning algorithms. This talk is intended for data scientists, data analysts, AI researchers, developers, and technical decision makers. All right, what is the agenda of today's talk? First, a list of customers already using AWS for their deep learning workloads. Then we will talk about the 3 things that you need to get the setup going. Finally, we will deep dive into the Jupyter Notebook setup on AWS. And the very last, I will show you a demo with few more details and also quickly run a deep learning algorithm. These are some of the customers running deep learning workloads on AWS. These customers are creating object recognition models based on convoluted neural networks, recommendation engines, NLP engines, deep reinforcement learning algorithms, etc. You may notice that we have so many more customer references than you'll find anywhere else for machine learning, because to successfully run an ML project, you need many services including data storage, security, identity management, etc., which are already available on AWS. All right, what are the things you need to run a Jupyter Notebook application? You need 3 things. First, you need to provision hardware to run your algorithms on. You can choose from a wide variety of instance types, which are intended for different workloads. For our workload, mainly deep learning training, you need instances with GPUs. Offload the processing to the GPUs and watch your algorithms speed up. After you choose your instance type, you need to choose an operating system. This comes in the form of AMI or Amazon Machine Image. In this talk, I will show you the most handy and cost-effective AMI that you need. The third aspect to decide is the machine learning software stack that is essential for your workload. All right, first thing, hardware. Amazon EC2 P2 instances are powerful, scalable instances that provide GPU-based parallel compute capabilities. P2 instances designed for general-purpose GPU compute applications using CUDA and OpenCL are ideally suited for machine learning, high-performance databases, computational fluid dynamics, computational finance, seismic analysis, molecular modeling, genomics, rendering, and other server-side workloads requiring massive parallel floating point processing power. P2 instances provide up to 16 NVIDIA K80 GPUs, 64 vCPUs, and 732 gigabytes of host memory, with a combined 192 gigabytes of GPU memory. 40,000 parallel processing cores, 70 teraflops of single precision floating point performance, and over 23 teraflops of double precision floating point performance. P2 instances also offer GPU Direct. It's a peer-to-peer GPU communication protocol, capabilities for up to 16 GPUs. So that multiple GPUs can work together within a single host. P2 instances come in three sizes: X large, 8X large, and 16X large. The name of the instance type is directly related to the number of GPUs that it comes with. In addition, the instance also has a proportional number of vCPUs and RAM, as you can see on the table here. You are charged for the number of hours you run your instance, and the per hour price depends on the AWS region you use. AWS has 16 regions today, and P2 instances are available in most regions, including US East 1, Oregon, Ohio, Mumbai, Seoul, Singapore, and more. When you choose your instance, the region, please be aware that the charges are region specific. The pricing is region specific. All right, deep learning AMI with GPU acceleration software. Once you have decided on the hardware, you will need an operating system to load, and this comes in the form of AMI, which stands for Amazon Machine Image. We call it AMI internally, or even outside of Amazon. You can choose Amazon Deep Learning AMI from the AWS Marketplace. The AMI has an operating system, and you can choose between Amazon Linux and Ubuntu. Just to clarify, it comes in two flavors, one which is loaded on Amazon Linux and other one on Ubuntu. The AWS Deep Learning AMIs offer GPU acceleration through pre-configured CUDA and CUDA drivers from NVIDIA, as well as Intel Math Kernel Library, MKL, in addition to installing popular Python packages and the Anaconda package manager. So this completely relieves you of the burden of installing any software or drivers. Right? It comes completely pre-installed. The AWS Deep Learning AMI comes pre-configured with Apache MXNet, TensorFlow, the Microsoft Cognitive Toolkit, CNTK, Caffe, Caffe2, Tiano, Torch, and Keras. It lets you quickly deploy these and any of these frameworks, so you don't have to ever install anything. And one important aspect here is the deep learning AMIs are free. The software is free. You only pay for the instance type and not for the AMI. All right, so we talked about choosing the hardware and then choosing the AMI. Let's talk about Jupyter Notebook itself, right? I'm sure many of you are familiar with Jupyter Notebooks because it is very popular among data scientists. When I first started using, we all have our favorite editors, right? But when I started using, I have my own, and when I started using Jupyter, I really fell in love with it because of the ease of use, because of the use through the browser. It's a web app, so that made things a lot easier. Here is a brief introduction anyways, even though you may be familiar with this, before we get into the weeds. The Jupyter Notebook is an open source web application that allows you to create and share documents that contain live code, equations, visualizations, and explanatory text. I really like the part where you can juxtapose code with the comments and context, and it looks very nice and makes the code very readable. People use it for use Jupyter Notebooks for data cleaning and transformation, numerical simulation, statistical modeling, machine learning, and a lot more use cases. The notebook application has support for over 40 programming languages, including those popular in data science, such as Python, R, Julia, and Scala. Notebooks can be shared with others using email, Dropbox, GitHub, and the Jupyter Notebook viewer. The code can also produce rich output such as images, videos, LaTeX, and JavaScript. Interactive widgets can be used to manipulate and visualize data in real time. I particularly like one JavaScript widget that I use for my demos, and it runs within the notebook. The Jupyter Notebooks are usually accessed through the browser. It's a web application, right? Behind the scenes, Jupyter Notebooks are an open document format based on JSON. They contain a complete record of the user's session and embedded code, narrative text, equations, and rich output. The browser itself does not do any processing, and the processing is actually done in the kernel. And the browser talks to the kernel using an interactive computing protocol. Kernels are processes that run interactive code in a particular programming language and return the output to the user. Kernels also respond to tab completion and introspection requests. So even though it may appear that the browser is computing, the browser is only rendering and showing you the output. The heavy lifting, the hard work is actually done by the kernel. All right, let's look at Jupyter Notebook running on your computer and how it works. The Jupyter Notebook is accessed using the browser. The browser talks to the kernel using an interactive computing protocol. The kernel is a processing engine. As you can see, this is a very simple client-server model. The client is the browser, and the server is the kernel. When I installed Jupyter Notebook application on my laptop, I was essentially installing the kernel. You could use any of the modern browsers. You could use any modern browser to access the notebook. Notice that even though I installed the software in my laptop, it is still a client-server model. The model has not changed here. But as I started using this, and it was very good, very nice for the initial models that I trained. And as my neural networks grew bigger and deeper, the training started to take longer and longer. And sometimes it took days to train the models. The reason it took longer was because the kernel was using my CPU on my laptop, which does not parallelize the computation. It's a very serial operation on the CPU. Deep learning training workloads involve mathematical operations on large matrices. GPUs were specifically designed for these kinds of matrix operations. If only I could offload some of my workload into my GPU, right? But my laptop was not intended for this. It was no longer convenient for this. But the P2 instances are perfect for this use case. Let's see how we can deploy this on AWS. I want to talk about this architecture first before showing you the demo, because it's very important to understand how it works. So this is an architecture diagram of a Jupyter application running on AWS, and you using the laptop browser on a laptop to access it. The key difference between the previous diagram and this diagram is the AWS instance on the right-hand side. The left side represents your laptop, and the right side is AWS. I have shown one P2 instance running the deep learning AMI and running a Jupyter kernel. The client-server model of the Jupyter application naturally fits here. So what might have looked like weird in a single computer, now it makes a lot more sense because now it's easily extendable to the cloud. All is not well yet. The problem is in the communication between the browser and the kernel. The communication goes over the internet to port 8888, the default port on which the Jupyter application listens on. There may or may not be authentication enabled on the Jupyter application. That depends on how you configure it. If you have not configured it properly, you could be leaving your Jupyter Notebook application open to the internet. This is a recipe for disaster. We at AWS take security very seriously. In fact, we often say security is job zero. This was one of the my motivations for creating this talk, to make this more secure. Let's look at how to make this more secure. Firstly, if you look at the right side, you will notice that the instance is placed inside a box called security group. Security groups act like a firewall, and it lets you block unwanted traffic. You specify the TCP ports to open when you create the instance. Here, we will not open ports unnecessarily, and especially port 8888. That is a default port used by Jupyter application. But only open the secure port 22 to be used for SSH. Next, we will create an SSH tunnel between your laptop and the instance through the port. This is where I get confused. I was getting confused a lot, and so I want to spend some time explaining how the SSH tunnel works. An SSH tunnel works similar to SSH. SSH, or secure shell, provides an interactive shell after you authenticate. Similarly, an SSH tunnel after authentication creates an end-to-end encrypted session. You will not get an interactive session when you create a tunnel. On the client side, in this picture, on the client side, after you create the tunnel listens on the port 9000. And any packet that comes into that port is encrypted and sent to the other end, and it enters the instance through port 22. It's very important. It does not use any other port. It enters through port 22 and is delivered to port 8888. The ports 9000 and 8888 are specified when you create the tunnel. They are not hard-coded. You can configure them to be whatever ports you need. They can even be the same ports. The whole operation of this tunnel is transparent to the client application, meaning if the user on the laptop points the browser to localhost 9000, behind the scenes, this is the port that the tunnel is listening on, so it catches any packets that comes into that port. These packets are then sent to the other side through port 22, and it reaches port 8888. The port 8888 on the instance is where the Jupyter application is running, and so it responds to that. The response again is sent back through the tunnel to the client. So, to the browser, it appears as though localhost 9000 is responding. A few things to note here. The tunnel works only through port 22. So you do not have to open any other non-standard ports in the security group, which is the firewall here. Also, the notebook session is only available as long as the tunnel stays. If the tunnel breaks for whatever reason, it could be because of network disruption, or maybe you shut down your laptop, you lose the connection. But this does not mean that the session is lost. Your notebook is lost. It's not lost. If you have saved your notebook, the file would be stored in the AWS instance. You can then re-establish the tunnel and continue your session from where you left off. Okay. So the next thing is to show the demo, but before I show the demo, I want to describe the steps one by one so that you can follow the demo easily. The first step is to launch an instance. When I launch an instance, there are a few things that I configure. You'll first see me choose the deep learning army from the marketplace, and then the instance type, P2 instance here. The third most important configuration is security group. Here you will see me open only the port 22 and nothing else. Once the instance has launched and is in the running state, I will SSH into the instance to start the Jupyter Notebook application. The Notebook application is already pre-installed, but you still have to start it. Notice that there is no software to install here because all the software that I need for this demo is pre-baked into the Amazon Deep Learning Army. The third step is to create the tunnel. We create the tunnel from the laptop. So the tunnel creation is initiated from the laptop. And the tunnel, the window in which you created the tunnel should stay alive throughout the session. If you close that window, you lose the tunnel. I want to specifically talk about two commands to understand the demo and also to understand the way to create a tunnel. The first command is to SSH to an instance. I am using a Mac, so the SSH command works on a terminal. If you use a Windows laptop or device, you could use a client like Putty, which has similar features. But I will not be showing that in this tech talk. I will use the SSH command lines. The command to SSH to the instance is this, the first one. SSH -i, the key file, and username at IP address. This has three parts. The SSH command itself, the first keyword, and then you provide the key file. The key file is provided for authentication. Notice that you will not be using a password. This will be using the key file. Then a username and password. This format, you need to get familiarize yourself with this format, because to understand the next line, this would be helpful. So creating a tunnel is also very similar. So you have the SSH keyword. Then we add a few options, -n and t, which is for creating a tunnel. But the most interesting thing is the -l option and the localhost option, right? -l, localhost 9000, localhost 8888. The rest of the command is providing the key file, username, and password. Sorry, I apologize. Username and IP address. Now, the only difference are the options here. The -L localhost 9000 and localhost 8888. This defines the two ends of the tunnel. The first port, localhost 9000, specifies that the port in which the tunnel listens to on the laptop, right? So localhost 9000, so it's when I say that, it's going to listen on port 9000 on my Mac. The second piece, localhost 8888, this is where the packets are going to be delivered to, right? An important thing to note, this command is run from the laptop. So the tunnel creation is initiated from the laptop. All right. That's all you need for the demo. Let's go to the demo. I have logged into my AWS account. I'm going to launch an instance. Choose learning. First, I search for the AMI. I search for Amazon Deep Learning on the AWS Marketplace. I have two versions. One is the Linux version, and the other is Ubuntu. I'm going to choose this guy. As you can notice, the charge for the software itself, this column, is 0. Then the next step is to choose my instance type. By default, it has chosen the P2 16 extra large. I'm not going to use that. I want to use the P2 extra large instance. It's showing me the VPC and other configuration. I'm not interested in that. Next is the storage. Right now, it's using instant store. If you want to have a persistent store, you can choose to add EBS volumes. We'll add a tag. The last configuration that I want to enter is the security groups. As I mentioned before, this is the firewall. And the option is to create a new security group or existing. I would like to create a new security group here. Showing you the SSH. Type is SSH, protocol is TCP, port range is 22. This says it's the source, like from what source is going to allow packets. I don't want it to come from anywhere. I want it to come from my IP. So it's going to allow traffic only from this IP. This is my IP to the instance, and only on port 22. So it's a very restrictive security group setting. All right, it's showing me a review. It's telling me that the configuration is not eligible for free tier because the P2 instances are not part of the free tier. And I'm going to be using the Deep Learning Army with Linux, Amazon Linux. All right, now I'm going to use an existing key pair. You could choose to create a new one or use an existing one. But for this demo, I'm going to choose an existing key pair. And the instance is launching. It usually takes a few minutes to launch. And while we are waiting, let's go back to the instance and see how it's. The instance state is running because we've started, and it's initializing. This is the previous instance that I started. I have terminated that instance, but it still shows up, which is fine. We have to wait till the status checks becomes healthy because it is now booting the operating system. All right, so we just saw the status check become healthy here. I passed 2 out of 2 checks. So the next step, so the instance is already running. It's a P2 extra large, running the deep learning army. Now let's connect to it. The next first thing I need to do is to start a Jupyter Notebook application in there. So I choose this instance and I need to connect to it using SSH. AWS provides this button which helps you. It's a helpful hint. It tells you what to do to connect. So here's a link to a documentation that helps you connect using Putty if you are using a Windows machine. I'm using a Mac, so I'm going to be choosing, I've already done the other 4 steps, change mod 400 webinar demo. That's the name of my key file. And I'm going to choose this. There's one thing to note in this. So I'm going to my terminal. I copy that command. There is just one change. As you notice, it's SSH -I, the key file, and root, the username at the DNS host name of the instance. The one thing to note is do not use the root user. The correct username is ec2-user. Okay, and the whole long thing in the end is the DNS name. So there's nothing to understand there. It's just a name. All right. Let's log into the instance. It's asking me if I want to continue. Yes. We are in. Okay. So we are in the P2 instance, and this instance already has all the packages that I need. I just need to start my Jupyter application. So I say Jupyter Notebook. Now the Jupyter Notebook application is started, and it says that it is started and it's listening on port 8888. If you remember the block diagram. So this localhost is not my laptop. It is the instance. It's telling that it's listening on its own port 8888, and this is the token. So copy this to your browser and see if it works. It wouldn't work because the security group is going to be blocking all traffic other than port 22. So what we're going to do, what do we need to do? We need to start an SSH tunnel. Okay. I'm going to take another tab and okay. So I've typed this command SSH options, then -L, the my end of the port in which I want the tunnel to listen on my laptop, and the port in which it's going to deliver the packets on the other side, and my PEM file, the key file, and EC2 user, the username, and the DNS host. Okay, when I do that, this is on my laptop. Remember this, I'm running this command on my laptop, and I've created an SSH tunnel. That is all you're going to see. You will not see any output. The tunnel is created, but it will not give you an interactive session. Now, let's go and see if the port 9000, so like I said before, I'm opening on the laptop side, I'm opening port 9000, and on the other side of the tunnel is port 8888, which is going to be delivered on the P2. I'm going to use the same link, but I'm going to just change this port number to 9000. Let's see if it works. This token is part of the link, is automatically generated when you start the Jupyter application, and it will change whenever you restart it. There you go. We have now successfully accessed the Jupyter application running on port 8888, but I'm accessing it through using localhost, that is my laptop's 9000, and boom, we're in. Okay, I'm going to upload. So let's do some deep learning training on a GPU. I'm uploading a notebook, Jupyter Notebook. It's a deep learning network to recognize handwritten characters from a database called MNIST. And it's asking me that the kernel is not found. It now wants to understand what kind of kernel it wants to run. I'm going to choose Python 3 and set kernel. As you can see, this is a Python notebook. You can add pictures, you can add text, rich text, and these are the cells which have the code. I want to click through this. It's going to first get the dataset. You can get the dataset and install it using the notebook. You do not have to use the SSH at all. Everything can be done using the notebook. I downloaded this IPython notebook from the internet, from the MXNet tutorials, so it's available for everybody. I did not write this program myself. Okay, once it's complete, it would provide a number here. All right, so you could execute each cell by pushing this button. I'm defining my network here, fully connected, activation layers, and other layers. Here's a picture of the network. And here is the training phase. We are training the model here. It goes through a loop and it's using SGD, stochastic gradient descent. And let's see, it's going to run on the CPU. So one of the things I want to show is to show you how easy it is to use a GPU on AWS. This is going to take a while. You can see each epoch 0 and epoch 1. Epoch 0 took 3.3 seconds. The first epoch was longer because it's probably loading the dataset into memory. And subsequent time cost is about 1.6 seconds, and that does not change much. So it's running in a CPU. This is a fairly small dataset and a fairly smaller network. So it's completed now, and you can see the validation accuracy is 97%. I'm going to run it with GPU this time. I changed the context to GPU and running it now. And you can see that the time cost now is reduced to 0.6 seconds. So one epoch takes 0.6 seconds. It previously took 1.6 seconds. So that's a 60% reduction in the time cost. This is a fairly conservative save speed up. I have seen some of my deep learning networks see 100 times speed up. What takes 100 seconds takes 1 second to run on the GPU. That is the way to start using GPUs. You could start using it in like 10 minutes. There's no magic to it, and it's available to everybody. All right. Cool. Let me just execute all the cells below. And that's it. That's the demo. So that was the demo. I hope you found it useful. And here are some useful references. Thanks for listening. So let's open it up for questions now.